First of all, the word logos in Greek means ratio. Yes, it also can mean word, verbum. In the beginning was the logos, but it is ratio, which means relationship. Before that occurs, all there is the one. The greatest philosophical question that there is how does the one become many? And we're going to look at that tonight. Now, ratio in terms of relationship, you can write it as a fraction, or let's say I just take my fingers like this. We say 1 is to 1, or 1 divided by 1 is obviously 1. Or 2 is to 1, 2. Or 1 is to 2. I've got to watch what fingers I hold up. Sorry. I forget where I'm at. You've got to be especially careful. This way is okay. So this would be, if you're reading left to right, that would be 1/2, or 1/3, or 1/4. Now, the key is how can one derive proportion, which in Greek is analogos, immediately from a single movement that gives you ratio but also gives you proportion immediately. There's only one way to do it. So, for example, if I take a yardstick, and this is going to help you see why the move to metric was a major mistake, I'm sorry. 36 inches in a yardstick. How many degrees in a circle? 360. So whatever happens with this yardstick multiplied by 10 applies to a circle and the divisions of a circle. Very important. Now, if this is the original whole, the 1, and I'm going to divide it, you might say, well, let's just cut it in half and let's see what happens. Well, if we do that, we'll find that we get 2 segments, each 18 inches long, but now the ratio of the whole yardstick to either one of those segments is going to be what? You tell me. This to this is 2 to 1. But this to this is 1 to 1. Are those the same ratios? No. So the immediate thing you realize is if there's going to be a solution, it's going to have to be an asymmetric cut. Not bilateral symmetry, it's going to be off center somewhere. Plato in the divided line begins with a cryptic statement. He says, take a line and cut it unevenly. There are several reasons why he does that. One, I've already hinted at. You already know the only way you're going to get the solution is going to be an asymmetric cut. Why does he say line? Well, he says line. Why doesn't he just use numbers, arithmetic, numbers? Because the Pythagorean quadrivium of mathematics is you have arithmetic, pure numbers, you have harmonics, which is music essentially, number in time, you have geometry, number in space, and then you have what they call spherics or astronomy, the movement of three-dimensional objects rhythmically through space and time, in other words. The answer to this is the solution is going to turn out to be an incommensurable or irrational number. You cannot get it by simply using a set of numbers because it would run on to infinity. But you can do it geometrically. So that's why a line, first of all, and also that's why you do it unevenly. You certainly can't do it evenly because you end up with 2 different ratios. Now, if you golden cut it, what you're going to find is you're going to get 2 segments. One is going to be, now remember this number, 22 and a quarter inches, 22.25 inches. Very significant. The other segment is going to be 13 and 3/4 inches, or 13.75 inches. Now here's the key. We now have the original 1 divided into 2 segments. One, again, 22 and a quarter inches, one 13.75, but here's the important point. The ratio of the whole to this intermediate segment, the longer segment, is in the golden ratio. The relationship of these two, same thing, golden ratio. the ratio of this to this is the same, identical to this is to this. It'd be kind of like saying this is, let's pretend this is 4, this is 2, and this is 1. 4 is to 2 is the same as, isn't it? 2 is to 1. Those would be the same ratios. But 4 and 2 and 1 don't add up to 4. In other words, this is the only possible way the divine or nature, chaos, I don't care what's doing it, can divide, and what it does is it fractalizes into the world. This is the Big Bang. This is the original scission, what the ancient Egyptians called the primordial scission. Because immediately, if you like Trinities, the Father manifests in the Son and the Mother here. Now what I want you to remember is this is the greater, this is the lesser, this is the geometric mean. This is the macro, this is the micro, the above and the below. But what you have to have is a bond. As Plato points out in the Timaeus, you'll see that in my talk tonight. You need a third factor. That third factor bonds together the other two. This becomes the geometric mean. That's why there are trinities in all of these religions. Brahma, Vishnu, Shiva. Vishnu is the second member of the Trinity that bonds together the whole with the lesser. Okay, I think that should do for there. One other quick item, and then we're going to hit the lights and we can look at this. This is a golden calipers. And this is an original one. This is ancient, and it's kind of damaged a little, but it'll work. No matter how wide or how narrow I make it, this, relative to this, is golden ratio. Golden section, scissors, scission, is where you cut it to get that relationship or golden ratio. That's why sometimes you'll hear golden section, golden ratio, or alternatively, when I use those three parts there, you'd have a golden mean between the extremes. Okay, let's show you. So if I take the phalanges of my finger, and it's the bones, it's not the flesh. It looks like I'm going to be fudging it here, but I'm not. So if I take the bone, go like this, and flip it over, you'll see that it goes to the medial phalange. If I take the narrow here now and do the same thing with the medial phalange, roughly there, hold it tight, flip it over, I should be able to get exactly the proximal phalange, which is the sum of the previous two. In a moment, we're going to talk about Fibonacci numbers. How many are familiar with Fibonacci's? Okay, you start with 0, and then you have 1. Each new number is the sum of the previous two. So 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2, 3. So it goes 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89. If you take, for example, a full twist of DNA, turns out to be 34 angstroms in length, 21 angstroms in width. If you look at the head of a sunflower, 34 spirals perhaps going one way of seeds, 21 the opposite direction. Or you might have 55 and 34, or 89 and 55, or even 21 and 13. But we'll see images of that. Now what's significant about that? That is nature's way of taking the golden ratio, which remember is irrational, and if you're going to count seeds or leaves or any objects, they're going to be whole integers, they're going to be whole numbers. It's nature's way of taking the divine proportion, another name for this golden section, and manifesting it in the world that we live in. That's why Fibonacci numbers are so significant. The majority of flowers well, almost all flowers are going to be Fibonacci. Sometimes there's a Lucas. Let's not deal with that now. We could, perhaps at question time, we could talk about that's a little tougher. But that's another number series that is actually even more perfect than Fibonacci because it's closer to what I would call Plato's forms, closer to the divine than even Fibonacci's are. But in both cases, they're expressions of this divine ratio in the world. Now here's what happened. When the primordial scission occurred, that becomes a fractal. It fractions, and it continues to fractalize from all the way to the top, all the way to the bottom, through the human body, down into the cells, down into the quarks that make up the subatomic particles, orbits of the planets. Kepler turns out to have been right. As John Martineau found, if you average out the orbits of the planets, you take their mean orbit and their mean diameters, it's stunning. They're all related, not just by the golden section. There are other ratios or logoi that are significant you're going to learn about tonight, particularly the square root of 2 and the square root of 3. Root 2 is going to come from a diagonal on a square, and squares make up the faces of cubes, and cubes represent Earth. They're one of the 5 Platonic solids. 3 of the Platonic solids you're going to see, tetrahedron, octahedron, and icosahedron, fire, air, and water, all have equilateral triangles. If you bisect them, cut them in half, you get square root of 3. These are what build up all of nature. Root 5 is also important where you take the diagonal of a double square, but you'll see that's how you create a golden rectangle. So square root of 5 is also significant. In fact, when you go to the Great Pyramid at Giza, has anybody been to the Great Pyramid by chance? Okay, so you've gone up the ascending passageway up to the King's Chamber. The ascending passageway is at 26½ degrees, which is what you get with that square root of 5. And if you go down, as I have, down into the, what Edgar Casey called the upside down chamber, same thing. It's a root 5 angle, 26½ degrees. In fact, Robert Temple discovered that on the summer solstice, on the back of the Great Pyramid, the Khafra's pyramid casts a shadow on the back of the Great Pyramid. If you've seen those pyramids, you know how immense they are. These people were geniuses. It casts a 26½ degree angle on the back of the Great Pyramid, which kind of reveals the secret of this square root of 5. Once you understand about that, you understand you're moving towards the golden ratio. I know, again, don't get caught up with problems with any kind of math phobia. It's not number crunching, it's patterns. But for those who want the numbers, the golden section, golden ratio is the square root of 5 plus 1 divided by 2, that's the greater. Or alternatively, the square root of 5 minus 1 divided by 2, that's the lesser. And when you have the greater and the lesser, here's what's interesting. Greater, actually, we tend to want to call 1.618. The lesser, 0.618. They're identical, but for unity or 1. That geometric mean that stands between the two, you're back to 1. And so if you subtract the lesser from the greater, you get unity. If you multiply the two together, you come back to unity. So again, everything revolves around the one, and then how the one allows us to move into manifestation. It's the most beautiful and the most functional way that is possible, as you're going to see. Okay, let's give it a shot. Okay, if you want to, great. So the golden section, nature's greatest secret, and we will have aspects certainly of the sacred geometry in here. So the golden section traditionally is associated with aesthetic principles, architecture, and art. That's where most people hear about it. Euclid, who comes out of Plato's Academy, where this was one of the great secrets. In fact, it was forbidden to reveal it openly. In fact, and this was for the Pythagoreans, those who were initiated in the Egyptian mysteries and those who were initiated at Eleusis. So let me tell you something, forget about that and listen to this. I go to Eleusis, if I go to Athens, first place I go to is Eleusis. That's where the initiations occurred. We now know that during the initiations, people who are blind would see. Same thing happens with near-death experiencers, as Kenneth Ring has pointed out. During the near-death experience, they see clearly, they describe later what they see. Of course, when they're back in the body, revived, they're not seeing. But here's another parallel. In these ancient initiations, as we're going to see Madame Blavatsky, I'll show you the quote. She says, during the initiations, the secrets of proportion were revealed. And she then says, and it behooves us to try to figure out what these proportions are. Same thing happens in near-death experiences. Same thing happens in visionary epiphanies. Happened to me in the rainforest in Peru while I was working with the shamans. In fact, my little golden section book here is the result, well, not the result, I worked on this for years and years and years. But when I had my epiphany in the rainforest and was taken out of my body, it basically confirmed that this is how nature and the cosmos, in fact, works. I wrote that book, by the way, in Glastonbury, some of it in Florida, but the majority was done at Glastonbury at John Martineau's Wooden Books facility, and it came out 7 months after I had this epiphany. Okay? So that's all part of it. Any questions so far? Okay, so let's get back to this then. So Euclid calls it division in extreme and mean ratio, or just DEMER for short. So if you look at Euclid's elements, you will find you begin with a point, a line, plane, build a solid. You then have ratios and proportions, root 2, root 3, golden mean, etc. You come to book 13. Almost all of the propositions begin with cut a line, and guess what? Division in extreme and mean ratio. In other words, do a golden cut. What you then do is you take the solids and you compare these ratio relationships, because that's how nature functions. What the mathematicians have missed is the fact that Euclid was not just coming up with these postulates from which you can derive deductively all these things. He was really saying this is how nature and the cosmos actually works. I'll show you another friend of mine who is working on that and is developing that further. So in Plato's Academy, he secreted this knowledge into his dialogues. It was absolutely forbidden to reveal it, but he was so smart, he figured out how to put it in there for people who understood what is known as abduction. The logic of discovery, which is really dialectic. It's coming up out of the cave. Most of you, I'm sure, are familiar with the cave. The prisoner chained, watching the shadows on the wall. There's light behind, doesn't know it. People are carrying objects, and those shadows are being cast on the wall. Prisoner is freed, forcibly turned around. Bright light begins to realize. And these are epiphanies. These are relative initiatory states of consciousness. And ultimately moves up out of the cave into the light, and this is where the abductive reasoning comes in. It's the only kind of logic that leads to new things, discovery. So it's the logic of discovery. Let's go back. Many striking successes have occurred in science, as I'm going to point out. Maybe there's an easier way to do this. Let's do this. And we're on the verge of a paradigm shift. The trouble is, many of the more fundamentalist skeptics, who are like fundamentalist people in religion, in science you get the same darn thing, and they go on the attack. When Schechtman discovered quasi-crystals in 1982, a Nobel Prize winner by the name of Linus Pauling attacked him and said, go read a crystallography book. You're an embarrassment to all of us. But that typically happens when something new comes up. Well, what happens is in 2011 he wins the Nobel Prize for his discovery, and it has everything to do with the golden section. Muhammad El-Nashi in 1994, he discovers that the golden section is at the heart of quantum mechanics physics. People steal his ideas and then they turn around and print it in Nature and in Scientific American. There's a big lawsuit. I'm in the Old Bailey. I have to defend the guy. It's a scandal. It's a charade. He loses. He tries to defend himself without an attorney, and big problem. However, in the end, this guy is going to be vindicated. El-Nashi is the greatest physicist that I know of, and I studied with Bohm, and he's the equivalent of David Bohm. Some of the greatest advances, well, I already said that. Max Planck, for example, states, a new scientific truth does not triumph by convincing its opponents and making them see the light, but rather because its opponents eventually die, sorry, I'll get this down in a second, and a new generation grows up that is familiar with it. Now one can no longer ignore the stunning advances with golden section consequences that have already occurred in all of these areas. Physics, chemistry, biology and cosmology, quantum mechanics, nanotechnology, the very, very tiny small crystallography, genetics, computing, digital information, cryptography, DNA structure. I mentioned the DNA structure. You realize the nucleotides, they now realize, organize with the use of Fibonacci numbers, which again, anytime, here's the point, you have two adjacent Fibonacci numbers, you have an approximation to the golden ratio. So for example, take the numbers 3 and 2. 3 divided by 2 is 1.5. Golden ratio is 1.618, etc. 5 is to 3 is 1.6, and so forth, or 1.666. 8 is to 5 is 1.6. So, let's see. Weather turbulence, we're going to see most of this anyway. Plant phyllotaxis. Phyllo is leaf, taxis is arrangement. By the way, your genius, who really was at the center of the winning of World War II, and in that incredible film, Imitation Game, that's come out, you folks, we now realize they had to keep this quiet. Alan Turing was studying phyllotaxis as a child. Albert Einstein discovered Fibonacci numbers in things like phyllotaxis, and both of them were convinced that they can find order in the cosmos and throughout. Planetary orbits and their sizes, as I've mentioned, black holes, even cosmogenesis, the very origin of the universe. Now here is the fellow who taught me Theosophy to begin with, Douglas Baker. We're in Cape Town, South Africa, at one of the international festivals. He introduced me to Helena Petrovna Blavatsky. Thank heavens, here we are, Blavatsky Lodge. She's the key figure. And here's what she had to say about Plato. Well, first of all, that Plato is a Pythagorean, primarily Pythagorean. And one of the fragments from Pythagoras you see here, and all things that can be known contain number. Without this, nothing can be thought or known. And Blavatsky says the following: Plato is the world's interpreter, not just one of them, but is the world's interpreter. I took her seriously on this. She also said the ideas of both Pythagoras and Plato are identical with ours as a theosophist, from the Key to Theosophy. The Mahatmas tell us that Plato was a fifth rounder, and the Mahatma letters to AP Synod. Siddhartha Gautama is a sixth rounder. They're way ahead of their time, coming back into the present to teach us, essentially. So when I was a student at the University of Minnesota, I looked into, and back then I could use that word. Nowadays it's very difficult to use the word occult. They even try to demonize the word esoteric. Plato's occult doctrine, and then I also worked on Platonic aesthetics at the University of Minnesota. Then eventually at the University of Florida, I did my doctoral dissertation. Originally I was working on Precognition in space-time. There were no jobs in philosophy very much, and so I went to law school, did my law degree, came back, changed my topic because I wanted to get this golden section and abduction stuff out. The Pythagorean Plato and the golden section, the study in abductive inference in 1983. In 1994, I went to Berkeley and did a summer program, Endowment of the Humanities, with Houston Smith. Some of you know Houston Smith, comparative religion, kind of the founder of that, and did this bit on Plato and the divine proportion, ascent to the first principle. But notice it's plural. Many people think that Plato only has the one or the good as the ultimate. No. You've got to have the one and what was known as the indefinite dyad. The big secret that could not be revealed is what the heck is the indefinite dyad. Well, I would be punished severely back then for telling you what I'm telling you right now. It turns out the indefinite dyad is the greater and the lesser golden ratio, as in its greater form, 1.618, and in its lesser form, 0.618. I'm just rounding them off. Then later, I worked on making this evident, the indefinite dyad in the golden section, uncovering Plato's second principle. That was done in Nexus Network Journal. And out of this eventually came the golden section book. And here, these are pages from the book that I made a poster and went to the 2007 Quantum Mine in Salzburg, Austria. Now, J. Kennedy, here in England, at Manchester University, made a major discovery regarding Plato's dialogues having this incredible musical structure. Plato encoded into the dialogues the Pythagorean harmonics, and where you find very beautiful things, concordance and so forth, you'll find that he's got the concordant notes where there are wars, hatred, all the bad stuff. It's discordant. But sometimes people, they'll go so far, but then they can't go any further because they think that they're going to go off into an area that's too far out there. Mere numerology, some of the physicists would call my subject. Others, they're so afraid that they'll be persecuted by others if they would go along with it. That's why Kennedy, he backed down. I had initially a dialogue, but it stopped. And then later, here's what I found on the internet, and I know exactly who he's talking about. Other scholars have identified the divided line as an allusion, not illusion, to the golden mean. Very strong arguments, etc. Now, he's not the one who discovered this. This has been known for some time. The divided line is strategically planted by Plato at the golden cut of the scroll that is the Republic. So Plato purposefully, hint, 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 put for those who have eyes to see and ears to hear, esoterically, the hints of what's going on. Surprisingly, now this is Kennedy, not me. Surprisingly, the Parmenides also has a passage near 61.8%, which, again, when you golden cut, initially, if the whole is 1, and you get 0.618, little baby phi, and then you get 0.382, which is phi squared. This is the trick. Most people cannot get this, and I'm not expecting you to right away either. It's later when you turn the whole, you transform the whole into 1.618, and then the long section that I showed you becomes unity, and then the shorter section becomes the little baby phi. But so 0.618, when you're doing a percentage, it becomes 61.8%. And then in addition, you find the language of Euclid's definition of the golden mean, the division of an extreme and mean ratio. Other dialogues discuss means and middles near the same point. Conclusion from all this is that it is now more probable that Plato's divided line is a deliberate and deliberately vague allusion to the golden mean. Thank heavens, Jay, you finally admitted it. Okay, so here's the first scission. Now, if this were 1, this would be 0.618, this would be 0.382, but relatively speaking, what happens is, if this is now treated as big, I call it phi, the greater, this becomes exactly unity, this becomes exactly what I call little baby phi, the reciprocal of this one here. So unity plus the lesser joined together gives you big phi. This is also the secret of the mystery of the Father being implanted into the Son. The one, the whole, becomes the one here relative to the lower here. Now, I'm not a big fan, especially after being at Montsegur and what the Christians did to the Cathars, but the Neoplatonists taught the Christians this secret. And literally, if you take the name Christos and translate it using gematria, it becomes 1480. Jesus is 888. You compare the two together, make a ratio, they're exactly 5:3. Very interesting. This is 0.666 of this. Usually, when there's something that is really divine and special, and they don't want you to know it, they try to make it sound like there's something diabolical related to it. So here's how it works. The whole line is to the upper, is the intelligible world of Plato. This is the sensible or visible world. Here are the forms. Here are the mathematicals. Here are the everyday objects. And here are the shadows on the wall. These are the artifacts and things that we create. Now, this is before I started to use the more refined imagery. This should be a big phi. These should have little bars on top. This should be the greater is to 1 and the same ratio as 1 is to the lesser. These two levels are identical in terms of that number. That's because once you awaken, this is slipped together with this, and it's just phi is to 1 is to phi. Greater is to unity is to the lesser. As long as you're in the cave down here, unawakened, asleep, as Buddha would say, you don't get this. But if you awaken, you become aware of this. And here's your Trinity. This is the deal right here. Very simple. You have the greater, big phi, and there's the number, is to unity in the same ratio as unity is to the lesser, little baby phi. Then in the Timaeus begins with a very cryptic statement, 1, 2, 3, but where is the fourth, my dear Timaeus? What has happened is someone who has been there, the philosopher, has become ill and is not present the next day. But Plato's always using this incredible cryptic language. The two ratios he reveals in the Timaeus are root 2 and root 3. This is always behind the scenes. This represents unity or 1. It's simply an equilateral triangle. When you take the square, the face of a cube, bisect it, there's your root 2. You take the face of either the tetrahedron, which has 4 faces, the octahedron, which has 8, or the icosahedron, which has 20. They're all equilateral triangles. And they all resonate with root 3. So 1, 2, 3, but where's the fourth? What Plato does in the Timaeus is he tells us that you have earth, air, fire, and water in the 4 elements, but the fifth one, the dodecahedron, is very, very special. It represents the entire cosmos, has 12 faces made up of pentagons. But then he doesn't tell us how to construct it. It is conspicuous by its absence. 1, 2, 3, but where is the fourth? That's because he would have been probably killed if he actually openly revealed. He was visited by the Nocturnal Council anyway. They accused him of revealing the mysteries of the initiations. He denied it in the 7th letter, but I can tell you right now, he did reveal it. But what you also need to know is you have to look at the fragments from Aristotle, and also realize that Plato had an inner esoteric oral teaching in the academy. When you start to put it all together, you can figure it out. But furthermore, at Timaeus 53a to 54b, what does Plato do? He gives us another big hint. He says, these then we assume to be the original elements of fire and the other bodies, root 2 and root 3. But the principles which are prior to these, deity only knows, and he of men who is a friend of deity. Anyone who can point out a more beautiful form than ours for the construction of these bodies shall carry off the palm, not as an enemy, but as a friend. He who disproves what we are saying and shows that we are mistaken may claim a friendly victory. Hint, hint, hint. Yes? And so here are your 5 Platonic solids. They're the only solids that have the same faces, identical faces all around, that fit perfectly into a sphere. And so, oops. So here is your tetrahedron, fire, and obviously anything on this side. These are all root 3. So your octahedron that I mentioned before, the air, the icosahedron, water, they all resonate to root 3. The cube, Earth, root 2. But the universe, the cosmos, or sometimes referred to as ether as well, is the dodecahedron with pentagonal faces. The problem is if you show how to construct a dodecahedron, you have to be able to show how to construct a pentagon. To do a pentagon, you do a pentagram, it's all golden cuts. So in effect, to reveal the dodecahedron, you revealed the big secret of the universe. So here's how, this is the original drawing of a discovery that I made that I want to share with you. And so you simply draw a square, you bisect it but down the middle rather than diagonal. You then bisect the half of the square, which in effect is a double square. Just think about this in your mind. If you look at this shape, it's 2 squares put together. There's the angle of the ascending passageway and the descending passageway. You now take your compass point here, pencil lead there. You see the arc. I don't have a movement on my computer for that, so I have to kind of fudge it. And you create a golden rectangle. So the whole thing here is a golden rectangle. Cut a square off, you've got another smaller golden rectangle. And as you know, look at the cover of my book, you see how it can fractalize. Take a square off of that, another golden rectangle. That's where you get the spirals in nature. But what I discovered, and I'm willing to share this, and we're putting it on the video for you, is compass point here, pencil lead there, arc down. That cuts this line in the square root of the golden ratio. I then drop that down here, so that's the square root of the greater. That is the greater itself, that's the length here. So that's big phi, square root of phi. There's the lesser, 0.618. This turns out to be very interestingly 1/2 square root of 2. In Gematria, what the Greeks did is they took and made names, or the name somehow magically, encode the geometry. So this is the god Hermes. This is going to be the god Apollo, which is root 2. This is root 3. These are exact. What I did was put together the fact that out of the womb of the golden ratio, you can get your root 2 and root 3. So it's kind of the mother of the whole bunch. And then you see how your squares are constructed in nature on that square root of 2 diagonal. Then you see here, if you look closely, before I go any further, you're going to see you have what's called the Vesica Pisces. And that's where, typically, if you look at any of the cathedrals, like at Chartres, you enter the west portal, there's Christ inside the Vesica, because that's square root of 3. And let's go further. So, what do I mean by that? This whole length here, this compared to this is root 3 is to 1. Or if you just take half of it, that little, oops, shoot, how did that happen? That little triangle there, and that bisector gives you root 3 as well. So to sum it up, I call this the golden chalice of Orion, greater, lesser, square root of greater, 1/2 root 2, exactly root 3, root 2. And then you can also apply all the names of the gods. They had figured out how to secretly put the names of the gods using gematria. Now you're going to say, well, what's that? Alpha, beta, gamma, delta, epsilon. Alpha's 1, beta's 2, gamma's 3, delta's 4, epsilon's 5. You then take the name, you decode the name, and you find they're doing sacred geometry. Now, why is the golden section really important? It's because phi the greater is the simplest continued fraction you can get. You come over here and you'll see it's 1 plus 1 over 1 plus 1 over 1 plus all the way to infinity. It's also the simplest nested radical. It's the square root of 1 plus the square root of 1 plus the square root. You see how unity, or the 1, which is the originator of the whole system, secretes itself back into the system. That's why this is not only the most beautiful ratio or relationship, it's also the most functional. So here I'm standing on the top of Khufu's pyramid. There's Khafra's pyramid. You might note these things, by the way. They had these things carved in such a way that these pieces would kind of lock together. Let's keep going because we've got a lot to cover. This is the sacred triangle, the internal structure that is so significant. So here is 1, half the length, or from the center out to the edge. That's unity, or 1. The greater, the square root of the greater, you just saw that in my diagram, is the height of the Great Pyramid, and then the apothem, the slant, is big 5. It's a monument to the golden section. Then in the Telesterion at Eleusis, this is where every year up to 4,000 people went through initiations. Forbidden to actually expose or bring out what happened, but I've been spending a lot of time studying the stelas, the grave markers, the poetry, etc., and you can begin to figure it out. In the Telesterion, they would spend the entire year, first of all, focusing, getting their mental set focused on their intention, and then the setting would be perfectly arrayed, and then they drink the kaikyan. We do not know exactly what is in the kaikyan. We have some ideas. I study all the plants. When I go there, even the plants that are still growing there today give us a pretty good idea, and it's not far different from what goes on in the rainforests in Peru. It's a different substance, however, it has the same effect. So here's what HPD has to say, most significantly. Now, I'm paraphrasing this first part. It is the golden proportional symmetry, because I know exactly what she's referring to. It was revealed in the ancient initiations, passed down by the adepts. She, of course, says the Atlantean, the fourth root race. And it is within this initiatory, but they're higher beings. Their efflorescence of the fourth root race. And it is within this initiatory tradition of the mysteries that, now here's Blavatsky, all the rules of proportion are those taught anciently at initiations, and one should acquaint oneself with the truly divine art and understand the deep esoteric significance hidden in every rule and law of proportion. Now what's interesting here is where you see any italics, that's Blavatsky, not me. I've colored it, I've underlined it, but this is all Blavatsky with emphasis. So here are our Fibonacci numbers, our 0, 1, 2, 3, 1, 1, 2, 3, etc. And again, we'll see heads of sunflowers or pine cones and pineapples. Each number is the sum of the previous two, so 34 is 21 plus 13 and so forth. Each number is approximately the previous number multiplied by the modular. Nature's modular is the golden ratio. Each number divided by the previous smaller number, 2/3 is 0.666, 3/5, 0.6, and so forth, is approximations to 0.618. Approximates, this should be little baby phi. It's a little error that's in there. So what actually happens? First of all, look at a pine cone. If you count the spirals, and this is a simple way to see how nature works. Tip the pine cone over. This one has 13 spirals going that way, 8 going the other. The pineapple here has 13. The more vertical be the higher number, 8 and 5. This is interesting when we come to Venus. We're going to see how this magical set of numbers is related to the relationship between the Earth and Venus. Furthermore, when you take 1 divided by 1, 1, 2 divided by 1, so between the 1 and the dyad, that's where everything unfolds now. 3 divided by 2, 1.5. 5 divided by 3, 1.666. 8 divided by 5, 1.6. And notice what's happening. It goes above and below, but the higher the numbers get, like here, 233 divided by 144, 1.61805. It's a little bit bigger, 1.6180339. Or here, 144 over 89, 1.679, a little bit less than. Higher the numbers go, they're collapsing into, they're being drawn towards the golden ratio in the limit. They never actually reach it unless you want to think in terms of the limit. But that's what's ruling nature. So here's a little cartoon, I guess. This must be Fibonacci's, they said. I don't know if you can read that. And they forgot the 0, though. Now, sometimes, by the way, in children's representations of this, and even sometimes they'll only start with the number 1, but technically the 0 should be there. But to expose this to children, oftentimes you'll see in these charts, they'll simplify it. So golden aesthetics. This is from the Hessar panel. Now I'm beginning to show you things that have not been published. These are in my Divine Proportion book, which is sitting there, and I will be down in Glastonbury on the 20th, of June, trying to get things squared away. But from Saqqara, Egypt, Russian architect Shevelev recognized that the 2 rods that are in here are in root 5:1 relationship. They're not golden, but they're that square root of 5 that I told you about before. And thank heavens we have remnants of this. I went and studied this at the Cairo Museum. Hopefully when they did damage in there, they didn't get to this. These are wood panels that have been preserved for an incredible length of time. My good friend Lance Harding, who is the world's expert on canons of human proportion, has studied with Keith Critchlow here at the Prince of Wales Institute in the VITA program, Visual Islamic and Traditional Arts. He's the one who's figured this out. And here's what's interesting. The more recent Egyptian canon is all based on Fibonacci numbers. So if you go to the navel, you'll find that at 13 it cuts. Now they go into the middle of the forehead, 21 squares up. Over here, the more ancient is interesting. It's Lucas numbers. Not only did the ancient Egyptians know about the Fibonacci numbers, and the Greeks knew it too, but the ancient Egyptians knew about Lucas numbers. When I was at the Chapel of Sacred Mirrors with Alex Gray, the visionary artist, and here's Lance Harding, we're holding E8, which is kind of the guts of physics, in fact, with all its golden ratios. Here's Zachariah Gregory, who also assisted in some of the drawings in my Little Golden Section book. And this is Dan Duddy, who is an expert with using these particular models. Here we have this is also at Chapel of Sacred Mirrors, Lance, and I'm taking a huge 3-prong caliper to show how it relates to the golden ratio. Mark Hord also has created this mask for plastic surgery to reconstruct faces that have been damaged. Also, the modeling agencies are using it as well. He studied Fibonacci numbers all over the planet in ancient cultures. Doesn't matter what race, they find that these things are interrelated. Now, Blavatsky again. Plato's initiatory knowledge of the ratios and proportional symmetry obtained in the Mysteries was preserved by Vitruvius, who gave to posterity the rules of construction of the Grecian temples to the immortal gods. He himself was an initiate and can only be studied esoterically. So then we come to Leonardo da Vinci. By the way, this analysis was done by Lance Harding. You see all the golden ratios. Luca Pacioli, the monk drunk on beauty, writes Divina Proportione, and it's illustrated by none other than Leonardo da Vinci. So the Golden Section book, written by Pacioli, which affected the Renaissance, is illustrated, for example, here with this dodecahedron by Leonardo da Vinci. He puts himself actually in this image here. This we used to think was da Vinci. This is actually Albrecht Dürer, who went to study proportion with Pacioli. And here's the Vitruvian Man you'll find you open up my little golden section book. I am most likely going to use this for the cover of my next For the Divine Proportion book. These are further geometric studies of Greek sculptures done by Harding. This is by Adolf Zeissing, studying the Apollo Belvedere. And in Minneapolis, I regularly used to go to the Minneapolis Institute of Arts. We don't have the Doryphorus anymore, which was a big bronze. We have a lot of Roman marble copies. Unfortunately, the canon of Polyclitus no longer exists, but the legend is that he infused it into the Doryphorus. So by studying that statue, you can get it. But all you have to do is study your own human body, and you can get it. Now, I took it seriously in terms of aesthetics, and I did the whole bodybuilding trip. That's me before I broke the back. But what happened is, and we're going to get to consciousness in a moment, what happened to me there was then able to be transported into very intense yoga in the rainforest, which allowed me to have epiphanies that otherwise I don't think I would have been able to handle. So here is another Lance Harding. This is after Desiderius Lenz, who at Monte Cassino did these incredible drawings and showing the different relationships using the golden section. Here I showed you initially, this one's after Michael Schneider, how the phalanges relate in golden ratios. So now we come to golden biology. Now, do I have permission to go as long as, since I started with all that introductory stuff, do I have permission from you to go until, say, roughly 8:30, then take our break, have our tea? Is that going to be okay if I have something really special to show you? Yeah. Okay, let's do it. Okay, now in this book on phyllotaxis, Symmetry in Plants by Jean and Barabe, in the foreword, they put the golden section right at the center. And this is the stuff that Alan Turing was studying. I've got an image of Alan Turing's mother. She made a drawing of Alan Turing as a child during a soccer match. A football match, and everybody's over there kicking the football. You know where Alan Turing is? He's stooped over. He's studying. It's either a sunflower or a pine cone. Yeah, that was his thing. Okay, so daisies and sunflowers are the emblems of leaf arrangement. Now these aren't leaves, certainly with sunflowers or florets, but it broadens out. All the problems of phyllotaxis are summarized therein. The presence of particular numbers, it flabbergasts him. Fibonacci numbers, an angle of 137.5 degrees. What did I do initially when I took the 36 inches and I golden cut it? It was 13.75 inches. If you golden cut the circle, you're going to get 137.5 degrees and 222.5 degrees. But where the next bud tends to come up on the stem tends to be at this golden cut, 137.5. They say the golden number, which used to be referred to as tau, from the Greek word tome, which means to cut. Today we tend to use 5 after the name Phidias, who used it on the Acropolis and the Parthenon, the Erechtheum, and other places up there. And forms in their capituli, pseudapices, demands an explanation, and has served as a spur to the human intellect. I mean, Kepler, Da Vinci, all the great thinkers, Plato, were into this and were trying to figure this out because it's out there in nature, but it's also going to be in here inside as well. It is in phyllotaxis that symmetry in plants is most striking and puzzling. And it demands an explanation, and that's what we're trying to do. The architect Oleg Bodnar, who I met in Ukraine, Odessa, during this big conference on the mathematics of harmony. It's a genius. And they're now expanding this phyllotaxis, and they're using what are called golden hyperbolic functions. But it's all golden ratio, but it's an extension of how nature in fact works. His book is The Golden Section in Non-Euclidean Geometry in Science and Art. So here is the golden cut of a circle, and as you see up in the top, 4 out of 5 of all species of higher plants have spiral phyllotaxis. There's only 3 basic ways it occurs. You can have distichous, like corn, where it goes at 180 degrees, so the leaves go out to the sides. Then you have whorled, it goes like this, and then at right angles like this, and you have the spiral. 4 out of 5 all plants use spiral phyllotaxis. Why? Because it spirals the water down to the roots. It allows for maximum exposure to the sun and maximum exposure to moisture and to pollination. And so it's the most functional, where the rotation angle is limited to a few values, and the most common is the golden cut. The golden heart. Now all of these things these are writers who I have included in the new book, which is not out yet, Divine Proportion, the mathematical perfection of the universe. And many of them are either coming out of Russia or the Ukraine. It's really sad what Putin has done in that relationship there. But anyway, cardiac performance in the timing cycles and blood pressure variations for man and other mammals is optimized by the law of the golden ratio. That's Tsvetkov. Biological cells. These writers, Spears and Bicknell-Johnson, demonstrated that an extension of Fibonacci numbers based on the Pascal triangle can model the growth of biological cells, and they conclude binary cell division is regularly asymmetric in most species. Growth by asymmetric binary division may be represented by the generalized Fibonacci equation. Now here's part of the secret. You're combining chaos and order. You're combining asymmetry with symmetry. Because what happens is, in an asymmetric cut off center, you're getting proportional symmetry. So it's a kind of symmetry where it's fractalizes. So each is related to the smaller and the larger in this kind of incredible symmetry. Pedikov in binary subalphabet, so you can see it's all golden section genetic codes. Kaproff and Pedikov, symmetries, generalized numbers, and harmonic laws and matrix symmetry in matrix genetics. Pedikov then works with and they write Mathematics of Bioinformatics. Again, it's all genetic code, golden section. You also get a bit of interesting stuff with, as you see here, this symbol with the yin and the yang and the Tao. And here's one of their matrices of hydrogen bonds in the golden section. Anytime you see these little phi symbols, it's all golden ratios in these charts. This one, an investigation of Fibonacci-like sequences in biology and mathematics. Golden human genome. A Frenchman, Perez, he figured out that a single-stranded whole DNA human genome, it's fractal, fine-tuned by the golden ratio. He also found 2 binary code attractors. The top state matches the lesser 0.618, and then the bottom is 1/2 of that. So instead of unity, it's 1/2 of the golden ratio, or 0.309. They create a kind of octave between each other, and genetics, we're starting to understand it now. Golden chemistry, same thing. Jukushko, he was at the conference, and he's discovered that there's an inverse Fibonacci number regularity in the periodic table of elements. By the way, the first initial periodic table was a set of spirals. It wasn't on the surface, and now we're going back, and he's contributing to divine proportion as well. And then we have Boyens and Lavendas from South Africa, actually. And in the same way that the golden ratio determines the phyllotaxis and packing density of nucleons and florets, like in pine cones and sunflowers, it also regulates the formation of chemical bonds. So even the Pauli exclusion principle being linked directly to big phi or tau, the golden ratio, the riddle's solved. The exclusion principle is dictated by the curved structure of space. You know that Albert Einstein discovered, I mentioned this earlier, he discovered Fibonacci numbers. He was bound and determined, because nature has it, that he was going to find it in space-time. Quasi-crystals, I mentioned this before, Daniel Shechtman, 1982. There's an ad hominem attack. They don't attack his reasoning and the merits of what he says, they attack the man. But he's attacked by another Nobel laureate, Linus Pauling, the same way they attacked El-Nashi. But Shechtman wins out, and in 2011, 29 years after his first discovery, he gets the Nobel Prize. But the Islamic, the Muslim structures, the geometry in the mosques, for example, at the Alhambra Palace, they're already doing it way back in the 8th century, and in the Darby Imam Shrine in Iran. And later Kepler and Penrose anticipate these quasi-crystals with their two-dimensional discoveries. And then there's carbon-60, which led to a Nobel Prize in 1996. They discovered it in 1985. And the story behind this is very interesting. By the way, here you see a pentagon surrounded by hexagons. Your hexagons give you hexagrams, which are your sacred symbol in Theosophy. They give you the closest packing of space. This gives you life and consciousness, where the pentagram comes into the picture. Here, this just happened back in April. I'm seated next to the Nobel Prize winner in my class of philosophy students, and we are discussing his discovery of carbon-60. You get carbon-60 when you cut the corners off an icosahedron. Icosahedron, if you take an edge of it, if that's one, you go across the other side, it's exactly the golden ratio. It nests together perfectly inside a dodecahedron where the vertices will touch the center. That's a whole other story. I'll talk in a moment about Venus. Here's the internal structure of your football. If an edge is one, you go across to the other side. It is a multiple of exactly, no approximation, 3 golden ratios, precisely. And then in science, we now, when we treat the HIV virus, they're using these fullerene drugs. Well, it turns out HIV is an icosahedron. The golden ratio, unfortunately, is not just used by all the good things in nature, it's all the bad things as well. And so it's very difficult to deal with, so they use these cages, put the medicines inside. Also, you see in nanotechnology, they're using all these incredible geometries related to both the 5 platonic solids, but also the 13 Archimedean solids. Buckyballs in outer space. In 2010, NASA's orbiting Spitzer discovered buckyballs, the largest molecules ever found in space, in a white dwarf star. Some now believe the golden structured buckyballs could be plentiful throughout the universe. One astronomer, Stangalini, maintains it is possible that it's the buckyballs with their golden ratios from outer space that provided seeds for life on Earth. Golden cosmos. Even the structure of the universe itself. Plato said it was a dodecahedron. Well, guess what's now happened? Back when they looked at the background radiation left over after the Big Bang, there were anomalies. And from these anomalies, they inferred logically, creatively, abducted, that the second and third harmonics of the cosmic microwave radiation background are weaker than expected. From that, they abducted. Their proposal is it's a dodecahedron. They've been waiting for this Planck telescope. It's back. We're now looking to try to determine whether the universe is flat, as many believe. But if it has any curvature, what they've already figured out is it's going to be a dodecahedron, or like Plato said, or something very close. And just so you recognize, I'm not making this stuff up. This is from Science News, November 8th, 2003. Now, what Martineau discovered is if you take the orbit of Mercury, you average it out. Now, it's elliptical, yes. Kepler had said already that he said, very interesting thing. There are two great treasures in geometry. One is the Pythagorean theorem, the other is a golden section. The one's like a measure of gold, the other is a precious stone. Hint. I can't go any, I'd be punished on that one. So what happens when you average out, this should have a circle around it. They decided this is their symbol for Earth, and I couldn't change it in my book even. So here's the Earth's orbit. Here's the orbit of Mercury. They're in phi squared. Golden section squared is to 1 relationship. Not only that, if you take the mean diameter of Mercury and of the Earth, guess what? Golden section squared. Now what's the golden section squared? Just like Fibonacci numbers, you basically start with phi, got to stick a 1 in there, phi, phi, fo, fum, phi, 1 phi, fo, phi squared is the sum of phi plus 1. It's 2.6180339. That's what they're talking about here. Here, if you study Venus over a 5-year period and connect up all the points where it's located, you'll find that it creates a 5-pointed star after 8 years. So you get 5, remember the numbers, 5, 8, and on Venus, guess what number it is? Number of years on Venus, 13 years. So just like that pineapple, 13 these spirals, 8, 5, the same. It's like the phyllotaxis we find in nature. 13, 8, and 5 are very common throughout our nature. And then more recently, this year, February 8, 2015, one from Scientific American, the other from New Scientist, they found that these stars that are fractal have golden ratios in them. Another hint from the cosmos. Golden consciousness. Okay, now we come to Penrose and Hammerlock. And they are saying, suggesting that in each neuron, but it's not just each neuron, every single cell in the it's not just the human body, every mammal, it's not just every mammal, it's every animal, every insect, every plant, every cell in nature has microtubules. And these are the quantum computers. Now guess what? These microtubules, and they're saying they're the motile, they move everything through the cell, they're the scaffolding, the structure of the cell, and they are the quantum computers. They're made up of 13 filaments, or tubulin dimers, and they spiral 8 one way, 5 the other, just like a pine cone. Penrose says, why do Fibonacci numbers arise in microtubule structure? You folks could answer him. He kind of knows already, but you folks already now know because it gives resonance. Everything, as Blavatsky said, is all atoms are vibrations. Everything is resonance. And so when there's transformations of consciousness, you're moving into higher states, you're going into higher resonance. You're resonating with a higher state of consciousness, maybe a higher being. Or you sit like Siddhartha Gautama under the bo tree, you go into what's called quantum coherence, you resonate with certainly the Earth, probably the galaxy, and possibly the entire universe. You identify. That's when Jesus says, I and the Father are one. He's making a very important statement, but it's not just Jesus, it's all of them. All of these incredible beings have gone into resonance, and they have downloaded the consciousness of perhaps the universe, I'm not sure. And at the tips of the microtubules are these very special clathrin molecules. They're Buckminster Fullerenes, they're buckyballs, they're your footballs. They're all golden ratios. So the structure of the quantum computers themselves is made up of these the microtubules, but at the tips of the microtubules, I think I've got it, yes I do, at the synaptic cleft, so here are the serpents the shamans see in visionary experiences. Here are the jewels at their mouths that they depict. These are the clathrons. This is the synaptic cleft. This is where transformation of consciousness occurs, and it's all resonance. Because the whole thing, we are set up, we are hardwired for transformation. And Edgar Mitchell is one of those who went through transformation on the way back from the moon. Not only did he conduct the telepathy experiments, and I remind you, statistically successful telepathy experiments from the lunar module to people here on Earth, but then even more so. Do you realize this is, NASA calls him the brain. He was the smartest of all the astronauts because his left hemisphere was going better than any, but his non-dominant hemisphere, where we now find in near-death experiences, part of that gets awakened. There are silent parts of the brain that usually aren't functioning. Well, he goes into samadhi. And then when he writes a paper called Nature's Mind, the Quantum Hologram, look what he says. It's been widely accepted the brain is just simply this regular computer. But the work by Hameroff and Penrose in isolating and describing, look what it is, microtubules in brain tissue have caused a re-examination of this and renewed interest in uncovering the quantum processes involved. So quantum computation. Here's my friend Alexei Stakov's book. Now this is his book. I helped him, yes, but this is his work. The mathematics of harmony. This is what the mathematicians missed that was already in Euclid, but they're going way beyond Euclid into non-Euclidean hyperbolic and what they call spherical geometry, both of the obtuse angle and the acute angle. Again, I'm not trying to let's hold some of the language down because I don't want you to get confused. The main thing is that the whole thing is a set of harmonics. His book is subtitled From Euclid to Contemporary Mathematics and Computer Science. Stakov has invented a revolutionary new golden microchip based on redundant number systems driven by what he calls Fibonacci P codes and codes of the golden ratio, what he calls P proportions. Okay, well this is all very esoteric to us. All I'm trying to get you to realize is this stuff is moving deeper and deeper into applications. And now in quantum computation and cryptography, it has the built-in ability to detect and correct itself in 99.98% all errors. This is almost unheard of. And it possesses perfect code coherence and flawless transmission of serial data. Phi-driven weather turbulence, chaotic climate dynamics by Selvin. Here's a quasi-periodic Penrose tiling pattern that was used being applied to turbulence. And here, courtesy of Dan Winter, here's what's going on in a hurricane. And here's Hurricane Sandy's Fibonacci golden spiral. Just take a look at what's going on. I mean, it's a no-brainer. Golden physics. David Bohm. That was my teacher. No, I wasn't. I'm not when he was that young. Here's what he says. The essential features of quantum interconnectedness are that the whole universe is in some way enfolded in each and everything, and that each thing is enfolded in the whole. As above, so below, and as below, so above. The key is we've got to figure out how to link the two, and that's where the third, the intermediate fact, the golden mean. That's why sometimes we call that golden ratio, the golden mean between the extremes. This is written up in the undivided universe. And what he's really saying is the universe is a hologram. You know, if you take a photograph and you cut it up into pieces. Let's say you have an apple on a photograph. You cut it up and you got a little piece of the leaf, let's say, corner of the leaf. And you put it on the copier and you blow it up. You're just going to have a little large little piece of leaf. If you take a hologram and shatter it into a billion pieces, made out of coherent laser light, you take one little piece where the leaf was, or the stem, blow it up, you get the whole apple. You and I are the whole universe in miniature. We are the Atman. We are Buddha consciousness, we don't know it. We are the Christ, whatever your language, again, it doesn't matter to me. It's just all of these teachings are really saying the same ultimate thing. And that's why Blavatsky and Theosophy is so darn important, because she got it right. She didn't get it wrong, she got it right. And not only are they saying, are you a hologram? Quantum physics says the entire universe might be, and we're fractal. That's the other thing. It's not exact at each level. It's self-similar. But at each level, the patterns reflect the other levels. There's self-similarity throughout the entire universe. So if you take any little part here and blow it up, you're going to see basically the same pattern. We are created in the image of the One, whatever that means. What did I do? Golden ellipse. According to the Polish scientist Grodzelski. Now we've got someone from Poland here. How would you pronounce his name? Oh, I can't do that. Do that again for us, louder. Grzędzielski. Grzędzielski. Love it. He says the golden ellipse derived from the golden section can be used as a geometric model for the distribution of light in optic crystals. Let's just drop down here. He also uncovered the physical sense of the golden mean as the main code of the universe, as the proportion of the thermodynamic equilibrium in self-organizing system. That's in the Stakov book that I showed you, that I helped translate from Russian into English. Okay, now in 2010, here in England, 3 labs, one at Bristol, where I'll be going shortly, one at Oxford, and the other one, the Rutherford Appleton lab, and then one in Germany. They're all playing with Heisenberg's uncertainty principle, and suddenly they discovered a signature at the heart of quantum mechanics, and they discovered the golden ratio, which others, and see again, this is why I started this out by saying usually when you hear golden ratio or golden section, people are thinking aesthetics, art. It's different. I mean, it is art, but it is also all of this mathematics in nature and physics, biology, etc. El-Nashi had already calculated the golden ratio behind the quark masses, fine structure constant. By the way, this is all, well, we'll see it. It's in my golden section book. And the chaos, listen to this, the chaos border between order and disorder, you go through a window. The window is ruled by the golden ratio. It's the most irrational of all irrational numbers. Almost counterintuitive. You'd think, well, it's got to be the most rational. No, it's the last one to go. It's the most incredible thing, and it's called literally the chaos border, the CAM theorem. And here's the actual title page, and you can see the date on it here. Up here, where are we here? Yeah, 1994 is quantum space, a random Cantor set with a golden mean dimension at the core. He was the most brilliant of the whole bunch. Here's an abstract from the fractal geometrical origin of quantum mechanics from Hardy's quantum entanglement. Hardy had discovered in entanglement a certain number, but he rounded it off. The only 2 people in the world at the time, according to El-Nashi, and I think it's true, who could have figured it out, they missed it because he rounded the number off. In the end, it turns out to be the golden mean to the lesser to the 5th power. And of course, that non-locality and entanglement, all the paranormal phenomena, all the things that we really are interested in are going to be discovered there. I even did a paper with El-Nashi, when 0 is equal to 1, a set theoretical resolution of quantum paradoxes. But here's the significance, and it's really El-Nashi's work. I entered in and helped, but my deal was really, we're on the threshold of a new era, what we're going to call golden physics. The power of the golden mean in these random Cantor sets resolves many of the quantum paradoxes, including entanglement, non-locality, wave collapse, and particle-wave duality. Now this one I do want to talk about just for a moment, because it's very, very important. If this is, let's say, a photon, an electron, a proton, I don't care what it is. Cut it here. This is the wave. This is the particle. If you multiply, if your consciousness, you know the double slit experiment. You look at a single slit, it looks like a particle, put two holes there, two slits, and you get wave phenomena. Well, if you focus and use your consciousness on the wave, the probability that's everywhere collapses into a particle. Somehow, if you're able to divide the particle with your consciousness, it will become a wave. This is it. And it solves that wave-particle duality. Okay, enough there. So in essence, in a paper, The Golden Mean Computer for High-Energy Physics by El-Nashi, a bunch of others. My name, by the way, was removed because there were a couple things in there I didn't like, and they didn't get corrected, and that's what they do. If you don't like it, boom, you're out of there. But anyway, it's very important, because why the golden mean? Well, there's several things. For those who are mathematicians, simplest, we already saw this, simplest quadratic equation, most irrational number, which in turn gives you the most stable periodic orbit. The reason we can stand on the floor is because of the golden section. Simplest continued fraction and square root rep. The reason behind it is Hardy's quantum entanglement that I mentioned earlier. But here's the basic thing. It looks like the universe is basically a golden mean or golden section, golden ratio computer, used extensively by nature. This is taken from my little golden section book. There's a Appendix 5 if you happen to get it. And by the way, you can get it on Amazon.com if you don't have it. I got it here for £6, a little tiny one there. It's also, by the way, let me just go back. What did I do? Shoot, Scott. Oh! Yes, thank you. And I think I can point the laser light. You know, that's just how smart you are sometimes. But what he pointed out, this might be easier to do this, that physics now looks like a cosmic symphony, and the quark masses are functions of the golden ratio. It looks like a harmonic musical ladder. Here it is. This is Appendix 5, one of the pages. And you'll see, here's your quarks. Here are their relationships. Here's the inverse Summerfield electromagnetic line structure coupling constant. And here's what I think they're going to discover, this thing right here with the Large Hadron Collider. This is what they're looking for the supersymmetry. And then all of the particles, in the end, you're going to see that they're ultimately made up of these quarks. It's all golden ratios galore. Here's El-Nashi with the Nobel Prize winner, Tufte. Here I am in Alexandria with him. This, I'm trying to rush too fast. He introduced fractals into physics, and El-Nashi likes me because of my little golden section book. Here we're at the Alexandrian Museum, where the library is. What El-Nashi discovered is you have to divide E equals M, you have to divide MC squared by 22. Why? Because 21 20-seconds, 95% of the universe is dark energy and dark matter. And so this equation really only applies to the matter part. Here we're receiving awards. This is my buddy. I didn't know I was going to receive awards. I had my Hawaiian shirt on. I didn't even have a tie on. My buddy here has his sandals on. We rush over. He calls me, "Get over here!" And here we are. Now I'm in Shanghai, China. We're doing a mini symposium on dark energy, which I chaired. And here with he, who is a genius, and El-Nashi, We did do a paper on dark energy and blah, 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 but you don't need to get into that. Dark energy and dark matter make up roughly 95.5% of the universe. And here's the equation. It's all related to the golden section. Here's El-Nashi, here's Einstein. Here he takes the hydrogen atom and its fractal spectra and quantum entanglement. We don't need to go through all this. The most stable, as I said, the most stable periodic orbit is that which has an irrational ratio of resonance frequencies. Since the golden mean is the most irrational number, it has the corresponding orbit that's the most stable orbit. That's why we find it everywhere. In a work by Merrick Krizak, Cantorian space-time theory, where she describes El-Nashi's work, you'll see here how everything is ultimately, all dimensions are going to be related to the golden ratio, ultimately moving into hyperspace. This is just a summary. We've already seen all this because I don't want to keep you over. We need to take our break in a second. This stuff is everywhere. Ubiquity, pervasiveness of the golden section throughout the sciences. On Sunday, I'm going to get into the New Renaissance. I'm going to get into the roots of the foundation of the Theosophical Society. Believe it or not, it resulted, yes, the Mahatmas, I believe, fully were behind it, but there was a lecture in the apartment of Blavatsky on ancient canons of proportion. That's what triggered the whole thing. And in the Temple of Man, Schwaller de Lubitsch, who spent 15 years working with...
About Feld.
I'm sorry?
Are you talking about Feld?
George Feld.
Yes, George Henry Feld. We're going to do that on Sunday.
Right.
And I'll go into the kind of the details. He was one of the first vice presidents. But many people have forgotten. And Claude Bragdon got a hold of the notes. And I went to the University of Rochester. I've studied them. And Bragdon, I was able to decipher pretty much.
Can you reveal?
I'm not sure. I can tell you that Bragdon makes it clear golden ratio was everywhere in those notes, as was root 2, root 3, and root 5. I can at least do that. And then, but really I should go back for 1 second. Golden section's not a product of mathematical imagination, but the natural principle of the laws of equilibrium. And here's what the Mahatmas say. We recognize but one law in the universe, the law of harmony, of perfect equilibrium. That's in chronological letter 90, which to me is the most important letter in the whole bunch. 88 is the one that Damon and I were discussing the other day, where they talk about God, whether God exists, the creative God or not. Probably was controversial. Those two letters I think are the most significant. One is number 10, the other I think is either 20 or 22. And as a result, golden section comes out, and the application, the reason today it's number 12 on Amazon.com in the US. I don't know what it is here, but it's number 12 in the history of mathematics. It's almost always in the top 20 on the history of mathematics now. And there it is. In the future, we'll have divine proportion, mathematical perfection of the universe. I probably will use Lance Harding's Vitruvian Man, because he did such a beautiful job with it. This is the stuff we discussed. I'm not going to read back through that. We can come back to it at the end if you want, after the break. But I know that's where questions come in. So if we want to come back to this, we can. And so that's it. Thank you very much.